After we have studied every part of the sampling system, it is time to integrate all these parts together and check some sample handling system designs. In every example, we will add or change a component of the system and see how it fits in the complete system. Let's start. In this example, we see a design that extracts a sample from the process and condition it and deliver it to a gas chromatograph. The design is segregated into 3 sections: the field section, the sampling panel section, and the analyzer section. Also, we can see that each component is identified with a number, and we can see in this table the description of the component with the sizes and technical specification. For example, number 5 is a 1/4-inch 2-way ball valve stainless steel 316. In the field section we can see the sample probe that extracts the sample from the process pipe and followed by sample process isolation valve, then the sample is transported to the sample conditioning panel through the sample line. We can see in this section the document number that contain the mechanical design of the sample probe. We can see the table describing the sample takeoff point tag in service, fluid phase, vapor or liquid, the pressure, normal and design values, and the process temperature, normal and design values. We can see also a table that describes the components of the process stream and its concentrations, the measuring range of the analyzer and the tag name of each measurement. We can notice the specification of the sample line is mentioned here: a 1/4-inch tube with 0.039 wall thickness, stainless steel 316 material, and the length of the sample line is 215 meter. Next, the sample arrives to the second section, which is the sample conditioning panel. First we have an isolation valve, then the pressure gauge, then a 3-way ball valve that switch between the sample gas or nitrogen used for purging or cleaning during maintenance periods. Then the sample reaches the bypass filter, divided to 2 directions: the direction of the analyzer and the direction of the return point, through a bypass flow meter with a needle valve to control the bypass flow as per the lag time calculation requirements, and a check valve to a low pressure return header. The low pressure return header is a header that collects all the streams that will be returned to the process and is directed to a point in the plant that has a stable and low pressure to provide stability to the complete header. The second direction is the analyzer direction. The sample exits the bypass filter to a pressure-reducing regulator. It decreases the pressure of the process, that is 2.78 bars to 1 bar, and maintain this pressure stable if the process pressure increase or decrease. After the regulator, the sample goes to an air-operated valve, called the stream valve. This valve has 2 sides that rotate together using the same signal. Each side has a common port marked by the letter C and 1 normally closed port and 1 normal open port. The normally closed port is the black one. If the valve is not actuated, this port is blocked or closed, and the common port is connected to the other port, the normally open one. If the valve is actuated, the common port is connected to the normally closed port, and the normally open port becomes closed or blocked. When the GC sends an air signal to actuate this valve, this means that the GC is ready to receive a new sample to be analyzed. So in this case, the sample flows through the valve to the sample flow meter with its needle valve to adjust the flow. Notice that, after the sample exits the stream valve, we have a pressure relief valve set at 1.5 bar, for overpressure protection in case of pressure regulator failure. Then we have a sample shut-off valve that is installed for safety purposes. It is normally closed valve and it always receives an air actuating signal to open the valve if all is normal. In case of any safety concern, the actuation signal will be removed from the valve and the valve will close, isolating the sample from the analyzer. Next, the sample goes to a flow switch that is used to confirm remotely that the sample flow is above its set point, for normal liters per hour. Next, the sample passes through yet another valve called an atmospheric valve. We will understand its function later, to a sample inline filter and flow restrictor, and finally to the analyzer sample inlet port. The sample exits the analyzer through the sample outlet port, to be returned back to the sample conditioning panel and to the same atmospheric valve, then onward to the same low-pressure return header. For gas chromatograph, atmospheric valve is needed to reduce the pressure of the sample to the atmospheric pressure just before sample is injected to the GC internal parts for analysis. That is the function of the atmospheric valve. When actuated, the valve blocks the gas chromatograph sample inlet port and depressurize the sample that is already inside the gas chromatograph to the atmospheric pressure through the gas chromatograph outlet port. We can also see in the sample conditioning panel the calibration valve that is used to inject sample from the calibration gas cylinder when needed, to validate or calibrate the analyzer. Also, the gas chromatograph require carrier gas to operate, so we can see the carrier gas cylinders and its regulators and relief valves to supply the gas chromatograph with the needed carrier gases. This example is exactly as the previous one, except that the sample line is PVC isolated for personal protection. We can see that the process temperature can reach -45 degrees Celsius, so we must isolate the sample line to prevent ice formation on the sample line and to protect any person that can touch the sample line. Also, this example is the same as before, but the sample line is steam traced. Also, the sample conditioning panel is heated using steam heater and temperature controller to maintain the panel temperature at 55 degrees Celsius. Also, in this example we need heat tracing, but in this case we use electrical heat tracing and electrical panel heater for better control of the sample and panel temperature. In this example we have added the pre-pressure reducing station before the sample conditioning panel to reduce the process pressure from 16 bars to 3 bars. Also, the lines are all steam traced. In this example we have two process streams that are measured using one analyzer with stream selection valves. The analyzers select the first stream. After the analysis is completed for the first stream, the analyzer select the second one and analyze it. Notice that the bypass flow is continuously flowing with no restriction to continuously provide a fresh sample to the sample conditioning panel to be ready for analysis once the analyzer is ready for it. In this example we noticed that the advanced reflux sample we discussed before is used to condition the sample at the sample tab point before it is transmitted through the sample line. Also, a sample pump is used to boost sample pressure to increase flow and provide good response time for analysis. In this example, the sample is liquid and it exits the sample conditioning panel to the analyzer liquid sample injection valve in the liquid state, and it is returned back to the process also in the liquid state. We notice that a sample cooler is used to cool down the liquid sample because the normal process temperature of the sample is 81 degrees Celsius. We see the cooling water supply and return header, and we can see the temperature shut-off valve installed at the cooler outlet. It has a set point of 49 degrees Celsius to protect the analyzer in case of cooler or cooling water failure. In this example, the sample is liquid and it is transported in the liquid state till it reaches the sample conditioning panel, then it passes through the bypass filter and then returned to the process in the liquid state. The sample directed to the analyzer is then vaporized using a steam vaporizer and the sample enters the analyzer in the gas phase. This is an example of a sample conditioning panel for a conductivity transmitter, the liquid sample pass-through, a sample isolation valve, a pressure gauge, a strainer that acts as the bypass filter, a pressure-reducing regulator, a sample flow meter, then to a flow cell that has the conductivity sensor installed in it and has a sample inlet and outlet port, then the sample is disposed of through a funnel for sample collection and drainage. We also have a line for lab sample collection for comparison. This is another example where we analyze the pH and conductivity of the same sample. The sample is steamed, so a sample cooler is installed to condensate the sample to its liquid form. A pressure reducer and a back pressure regulator are used to set the sample pressure at 0.5 bars, and temperature shut-off valve is used to protect the sensors from high temperature sample in case of any failure in the cooling system. This concludes our course. Hope it was clear and valuable to you, and it would benefit you through your career. If you have any questions, please ask them and I will do my best to answer all your questions as soon as I can. Thank you again.